Hi, today we have to discuss the relation between simple random sampling and stratified random sampling and systematic random sampling. Statement: if the population consists of linear trend, then prove that V of y bar st less than or equals to V of y bar SYS less than or equals to V of y bar n. So now we have to start the proof. So before that we start that proof, just provide this some notation format. So in simple random sampling without replacement, variance value capital N minus small n by small n capital N into S square, and in stratified random sampling the variance value V of y bar st is equals to 1 by n square summation j ranges 1 to n nj into nj minus small nj by small nj into sj square from systematic sample mean. So the variance of sample mean in systematic random sampling 1 by k summation I ranges 1 to k y bar ni dot minus y bar double dot whole square. So now we have to consider the population units as a. So I equals to I. So for all I ranges 1 to up to capital N, and capital Nj is equals to k, small nj equals to 1, capital N is equals to k into n. So we have to consider this type of population units. From these considerations, now we have to find the population mean. So capital Y bar capital N is equals to 1 by capital N summation I ranges 1 to capital N yi. So in that yi we replace the I. So 1 by capital N 1 plus 2 plus up to capital N. So the 1 plus 2 plus up to capital N we have to replace n into n plus 1 by 2. So already 1 by n is there. So n cancel, we get the value. So the capital Y bar capital N is equals to capital N plus 1 by 2. Now we find the population mean square. The population mean square we can define it by the capital S square. So the capital S square is equals to 1 by n minus 1 summation I ranges 1 to capital N yi minus y bar n whole square. After simplification, the population mean square convert into 1 by n minus 1 summation I ranges 1 to n yi square minus n into y bar n square. So already we know that yi we treated as a I. So the yi square is equals to we replace I square, and y bar we can find the value n plus 1 by 2. We replace that value. So the I square we can replace 1 square plus 2 square plus up to n square. So we have to return the value n into n plus 1 into 2n plus 1 by 6. So we substitute that value. So we get that s square equals to 1 by n minus 1 n into n plus 1 2n plus 1 by 6 minus n into n plus 1 whole square by 4. So we take common n into n plus 1 by 2. So already with there n minus 1. So we get the value 2n plus 1 by 3 minus n plus 1 by 2. So here we take the LCM, we get that value 6. So here 3 is there, just we multiply the 2. So 3 get that 4n plus 2 minus. So here we get the 2, we multiply the 3. So 3n minus 3. So the total value 4n plus 2 minus 3n minus 3. We get that value n minus 1 by 6. So after simplification we get that n minus 1 by 6, and the remaining term n into n plus 1 by 2n minus 1. n minus 1 cancel. So finally we get that s square is equals to n into n plus 1 by 12. Now we take the simple random sampling without replacement. The variance of sample mean is equals to capital N minus small n by small n into capital N into s square. So we know the s square value n into n plus 1 by 12. We replace that value. So we know that the capital N we can convert into k into n. We substitute that value. So in that place of capital N. So k into n minus n by small n into kn plus 1 by 12. We take common for n. We get the value n into k minus 1 by n into nk plus 1 by 12. So nn cancel. Finally we get the value. We have y bar n r is equals to k minus 1 into nk plus 1 by 12. Variance of sample mean in simple random sampling without replacement, we get the value k minus 1 into nk plus 1 by 12. So now we consider the variance of stratified sample mean is equals to 1 by n square summation j ranges 1 to n capital Nj into capital Nj minus small nj by small nj into Sj square. So already we consider the nj is equals to k and small nj is equals to 1. We replace that value and also capital N equals to k into small n. So V of y bar st is equals to 1 by k into n whole square summation j ranges 1 to small n k into k minus 1 Sj square. We know that population mean square capital S square is equals to capital N into capital N plus 1 by 12. So from the population of capital N unit, since the jth stratum consists of k units, so capital S square j is equals to nj into nj plus 1 by 12. Already we have to consider capital Nj is equals to k. We replace that value k into k plus 1 by 12. Sj square is equals to k into k. Variance of stratified sample mean is equals to 1 by n square k square summation j ranges 1 to n k into k minus 1 into k into k plus 1 by 12. That is the Sj square value. The k square value we cancel. Finally we get that 1 by n square summation j ranges 1 to n k minus 1 into k plus 1 by 12. In that summation value constant we get that value n into. So nn cancel. Finally we get that V of y bar st is equals to k square minus 1 by 12 into n. So after completing variance of stratified sample mean, now we have to consider the variance of systematic sample mean. So in that proof, just we consider the sample of size n will consist of the units I comma I plus k comma I plus 2k comma dash dash up to I plus n minus 1 k units. So from these observations we have to find the mean of ith systematic sample mean. Y bar I dot equals to 1 by n summation j ranges 1 to n yij for all I ranges 1 to k. In that yij we replace the value I plus k, I plus 2k dash dash I plus n minus 1 into k. So in that I term we repeated ni times. So k we take the common, we get the value k into 1 plus 2 plus 3 plus up to n minus 1. So in this series we have to write n minus 1 into n minus 1 plus 1 by 2. Here minus 1 plus 1 cancelled, we get that final value n into n minus 1 by 2. Already we have k by n, nn get cancelled, we get that I plus k into n minus 1 by 2. From the population mean, capital Y bar capital N that equals to Y bar double dot. So the value we can find out n plus 1 by 2. So the capital N we can replace k into n. So Y bar double dot is equals to nk plus 1 by 2. So now consider Y bar I dot minus Y bar double dot is equals to I plus n minus 1 k by 2 minus nk plus 1 by 2. So here we take the LCM. So I plus n minus 1 k minus nk plus 1 by 2. So we multiply the term nk minus k minus nk minus 1 by 2. So nk cancel. Finally we get that I minus common k plus 1 by 2. So variance of systematic sample mean 1 by k summation I ranges 1 to k y bar I dot minus y bar double dot whole square. So we replace the value y bar I dot minus y bar double dot value I minus of k plus 1 by 2 and whole square. So it's similar to a minus b whole square form. Just we write that a square b square minus 2ab. So in that minus 2ab we have to cancel two terms. So and we apply the summation 1 by k ni square plus 1 by k summation k plus 1 whole square by 4 minus k plus 1 by k summation y. Summation I square, we replace that k into k plus 1 into 2k plus 1 by 6 and summation yi replace k into k plus 1 by 2 and k plus 1 by 2 we take common. So we get that value 2k plus 1 by 3 plus k plus 1 by 2 minus k plus 1. So we take the LCM. So k plus 1 by 2 into k minus 1 by 6. So V of y bar SYS is equals to k square minus 1 by 12. So from variance of simple random sampling without replacement comma, stratified random sampling and systematic random sampling, we get that V of y bar ST east, V of y bar SYS east, V of y bar n is equals to k square minus 1 by 12n east, k minus 1 into nk plus 1 by 12 east, k square minus 1 by 12. In that k minus 1 is the common, so and by 12 we cancel the term. We get that k plus 1 by n east, nk plus 1 east, k plus 1. In this term approximately we get that value k plus 1 for 3 values. So from that we get that 1 by n is to n is to 1. So from this value in stratified random sampling we get that 1 by n and systematic random sampling n and simple random sampling 1. So simply we say that this is a V of y bar ST is less than or equals to V of y bar SYS less than or equals to V of y bar n simple random sampling. Thank you everyone. So please subscribe my channel. My channel name Baswaraju Buyya 2023.